Okay, so this is our first example of an elastic conservation of momentum problem, an elastic collision. So Tubby and his twin brother Chubby have a combined mass of 200 kilograms and are zooming along in a 100 kilogram amusement park bumper car at a velocity of 10 meters per second. They bump Melinda's car, which is sitting still. That means Melinda is moving 0 meters per second. Melinda has a mass of 25 kilograms. After the elastic collision, so it's telling us that they're going to bump and separate. The twins continue ahead with a speed of 4.12 meters per second. How fast is Melinda's car bumped across the floor? So here's how we're going to start working on this problem. Okay, we have our bumper car diagram. So here I have Tubby and Chubby weighing 200 kilograms combined, and their car weighs 100. They are moving along at 10 meters per second. Here's Melinda, who I drew a little smaller. She's 25 kilograms. This cart is moving 0 meters per second. Now, what I have to remember is, since they're both in bumper cars, I was told that this bumper car weighs 100 kilograms. So we know that this bumper car will also weigh 100 kilograms, assuming, it's in the same ride, so they should weigh the same. So this is before. Bam, the cars collide. Now, afterwards, Tubby and Chubby are moving 4.12 meters per second, and we want to know how fast is Melinda moving after the collision. So we had to start with our givens. We know Tubby and Chubby together weigh a combined 200 kilograms, or rather have a mass of 200 kilograms. The bumper car has a mass of 100. Tubby and Chubby's initial velocity, I, is 10 meters per second, and their final velocity is 4.12 meters per second. Melinda has a mass of 25 kilograms. Her initial velocity is 0 meters per second. The unknown is final velocity of Melinda. Now remember, we have to include the bumper car for Melinda. It wasn't given here, but we know she's in one, so we have to include that. So we're going to know right away it's an elastic equation, so we have to set it up where our momentum of the first object initially plus the momentum of the second object initially is going to be equal to the final momentums of both objects. So this is our initial equation, the original equation. What we're solving for here is V2 final, the velocity of the second object after the collision. So we simply are going to do some very simple algebra. We're going to keep the initial first side of the equation here. And since we're adding these together here, we're going to take the momentum of the first object after the collision, and since we add it on this side, we're going to subtract it here. Okay, and then that leaves us with this left. So what we will have to do is get velocity alone. Now we're multiplying. So we have to divide out the second mass, and that's how we get this here. Okay, and we set it equal then to the second velocity final. As we plug in, the total mass of the first car is 300 because Tubby and Chubby were 200 kilograms and the cart is 100. It was moving 10 meters per second. These two numbers get multiplied. That's going to give you 3,000 kilogram meter per second. Then we get the momentum of the second object, Melinda's car. She weighs 25 kilograms, but the car weighs 100. We multiply that by her initial velocity, which is 0. We get 0. So right now we have 3,000 plus 0. Okay, now we have to subtract out the final momentum of Tubby and Chubby's cart. They together have a combined mass of 300, and their final velocity is 4.12. So we multiply those together, and we get 1,236 kilogram meter per second. When we do the subtraction, our final number is 1,764 kilograms meter per second is in the numerator. Now, what are we dividing by? We're dividing by the mass of the second object. That's Melinda plus her cart, which combined is 125 kilograms. When we divide 1,764 kilogram meter per second by 125 kilogram, we get the final velocity of Melinda's cart is 14.1 meters per second. And that's how we solve that elastic collision problem.